Today we are going to learn about the practical of YouTube. So this is YouTube. So we are going to use YouTube to compare the densities of two different liquids which are not mixing with each other. So as an example, you can see this is kerosene oil and this is water. So kerosene oil and water not going to mixing with each other. So in here we are going to find out the ratio of density of kerosene oil to the density of water. This ratio we are going to define as the relative density of kerosene oil. So I am going to draw the YouTube now. In the YouTube, first I am going to add the density which has the higher than the another. First I am going to pour water into this YouTube. Now you can see the both water levels is equal. Then I am going to add kerosene oil later. So this is the intermediate position. Such kind of diagram won't be happen because after adding water levels going to be balanced, but I am going to draw it. So after adding the kerosene oil, we can see. So this is called common interface. So common interface will be moved out. So kerosene oil column now bit move down and water level going to be rise up. So I am going to find out the new common interface. I am going to take the height of the liquid column from the common interface as HL, while height of the water column I am going to take as HW. And I am going to take the density of liquid as rho L, and I am going to take the density of water as rho W. So I am going to take the common interface level is AB. So we know pressure of point A is equal to pressure of point B because in the homogeneous rest liquid, pressure is equal in the same horizontal level. So I am going to write down now PA is equal to PB. PA is equal to PB. So we know PA is equal to atmospheric pressure plus HW rho WG. PB is equal to phi plus HL rho LG. So you know, so both levels are equal. So therefore, phi plus HW rho WG is equal phi plus HL rho LG. So phi and G will be cancelled it off. HW rho W is equal to HL rho L. Now what we are going to do is in here, we are going to change the height of the liquid column and we are going to find out the relative balancing height of the water column. So in this experiment, we are going to change the height of the liquid column. So I am going to keep subject HW in here. HW equal rho L over rho W into HL. So this is get the format of Y equal mx. So in this experiment, this is the things that we have to do. In here, we have to change the height of the liquid column. And we have to find out the relative balancing height of the water column in the opposite side. So in this experiment, I have told you first we have to add water. Instead of water, if we add kerosene oil to in here, in other words, if we have add the liquid which has a lower density, and after if we add the density which has a higher liquid, so the density of lower liquid column might be cracked and that can be added to the both terms. So we are not going to add the lower density liquid first. Now I am going to show you. Now I am going to add water to the column first. Now you can see this is water. Now I have added water into here, and you can see the common both interfaces are in equal nearly here. You can see the water upper meniscus in here in both arms. So then I am going to add I have already drawn a table to represent the relevant values in this chart now. And now you can see, you already seen that I have added water to the YouTube. And then I am going to add kerosene oil to the next one. Now you know, in YouTube, it already include half meter scale. But in here, the least count of the scale is 1 millimeter. So you know, now we are going to measure the height of both liquid and water column from the common interface. So in order to get the accurate reading of length measurement, we know the minimum height should be greater than 10 centimeter. Now I am going to get the first reading now, but now you can see in this video, now you can see the common interface in here, and this is the upper meniscus position of the kerosene oil column, and this is the upper meniscus position of the water column. Now we are going to get the first reading in this experiment. In here we have to measure height of the kerosene oil column versus the height of the water column from the common interface. Now you can see this is the common interface. This is the layer separation of both water and kerosene oil. The position would be in here is 16.7. 16.7 centimeter is the position of common interface. Now I am going to find out the upper meniscus position of the kerosene oil column. In here we have to use either set square ruler to get the position. Its position look like 27.6. The upper meniscus position of the kerosene oil column is 26.7. So using this difference, we can get the height of the kerosene oil column. 10. The height of the kerosene oil column is now 10 centimeter. Now I am going to find out the relative height of the water column. However, I have to measure the height of the water column also relative to the common interface. level. So I am going to find out the upper meniscus portion of the water level now. It is 25.5. 25.5. Now, height of the water column is 8.8. So I am going to write down my first coordinate now. I am going to write down my first coordinate is 10.0, comma 8.8. This is my first coordinate. Again, I am going to add kerosene oil again. Now, after adding, common interface portion will be changed now. First, I am going to find out the new portion of the common interface. It is 16. It is 16.0. Now I am going to find out the upper meniscus portion of the kerosene oil column. It is 29. Therefore, difference is 13 centimeter. Now I am going to find out the upper meniscus portion of the water column now. It is 26.1. It is 26.1. Therefore, now we already find out the second coordinate. It should be 13, 10.1. Now I am going to again add kerosene oil, the right hand side down. Again, common interface position going to be changed. The new position is 14.5. The upper meniscus portion of the kerosene oil column is now 31.3. 31.3. Therefore, difference is 16.8. Now I am going to find out the upper meniscus portion of the water column. It is 27.5. Therefore, new coordinate is 16.8, 13.0. Now I am going to get the fourth reading now. Now I am going to get the fourth reading now. The new common interface in here now. This is the new portion of the common interface. New position is 13.5. 13.5. Upper meniscus portion of the kerosene oil column is 33 now. Upper meniscus portion of the water column is 28.7. 28.7. The new coordinate is, the fourth coordinate is 19.5, 14.2. Now I am going to get the fifth reading now. Again, I have to add kerosene oil. New reading is, now first we have to find out the position of the common interface. It is 11.7. It is 11.7. The upper meniscus position is 35.7. 35.7. Upper meniscus portion of the water column is now 30.4. 30.4. Therefore, new coordinate is now using this data table. Now, in this experiment, now we have to plot the graph using these even details. If we plot the graph, now x-axis will be represented the HL, should be centimeters, and this should be the vertical axis HW. So once we plot the graph, we have to find out the gradient of the graph. We know tan theta should be equal to rho L over rho W. So we can find out the relative density of the given two liquids using the gradient of the graph. Certain things that we have to memorize while doing this practical. If we use YouTube, which has two different cross-sectional areas with the two different arms, it is not impact for the practical because cross-section area of the arm will not impact for our practical. Because why? In here we are going to find out, we are going to keep equal the pressures into different level, PA and PB. So you know P is equal to pi plus H rho G. So cross-sectional area is not impact for this reading because pressure will depend only the height of the liquid column, not depend with it's the cross-sectional area. And question might ask, in this experiment, what are the readings that we have to take in this experiment? What are the readings that we have to take in this experiment? What is the first reading? First reading is position of the common interface. Second and third readings are the positions of upper meniscus position. Positions of the upper meniscus position. In other words, if we want to get the height of the kerosene oil lamp, what are the readings that we have to take? The lower position mean the position of the common interface and upper meniscus position of the kerosene oil column. So using that difference, we can find out the height of the kerosene oil column. In here, upper meniscus position of the water column and position of the common interface. That difference will be provide the height of the liquid water column. And in here, if we want to, even in here, if we want to compare the densities of two different liquids which are mixing with each other, if we want to do it using the same U-tube, we have to add little bit amount of mercury to the arm, because that will, the mercury will separate two arms. In here, in this experiment, we have to use the two different liquids, the densities. Densities near equal. Density should be near equal. What is the reason for that? In this experiment, this is the common interface. So this will be the new liquid. If the densities are nearly equal, the height of the liquid columns are nearly equal. Once we plot the graph, the data distribution of the graph is if we plot the graph, the dispersion of each point is equal. That's a good data distribution in the graph. But if we are going to use a liquids like water and the mercury, it is impossible to do using this portable YouTube pipe, because if we want to change the small amount of height of the mercury, we need the significant height of water column, right? So usually we are going to use YouTube to compare the densities nearly equal. In such kind of one, it is unable to do the liquids like mercury and water. I'm going to explain how to find out the gradient in the given graph. So assume this is the lower position of your graph and this is the upper position of your graph. So you have to select two different points to calculate your gradient. Your selected point should be in between this figure. If you are going to extend the graph in like that, you can't select the point in above away from the region. So your point should be in between this particular region. So how to find out the best points now? If you are going to move downward from the upper edge, so now I am going to draw the grid of the graph. Right, the first point. This is the first point. It already go to the two intercepting lines like that. This should, the first point, once you are going to come from the top into the lower, this is the first point like that. Go to two intercepting lines. So you have to mark that point called. You have to show you are used point to calculate the gradient. So I am going to mark that point A, x1, y1. And once you are going to move upward from the bottom, the first point, it should go through two intercepting lines. This is the point. So I am going to mark that point B, x2, y2. So then tan theta is equal y1 minus y2 divided by x1 minus x2. Both these 2 points should have the maximum dispersion in this graph, and these two selected points should be in between the given range of the graph. Now let's go through the structure question discussion tute. You are required to determine the relative density of a liquid using YouTube. What is the principle behind it? The principle behind the YouTube is the pressure law. For an homogeneous rest liquid, pressure is equal in same horizontal level. The pressure law is the concept that we are going to use in the both YouTube and hair apertures. What is the important property of the liquids that you used in this experiment. These two liquids should not mixing with each other, and the densities are nearly equal. There is a two different properties. Is the uniformity of the YouTube important in this experiment? Few reasons. No, because it is only depend with the height of the liquid column. Cross-sectional area will not impact for the pressure of the liquid columns. So part D will ask, the density of liquid is greater than of water. Which you should for first reasons. We have to add the liquid which has the higher density first. If not, if we add the density which has a lower density, it might crack and can be added to the both arms. Try two precautions you would take when pouring liquid into your tube. Before get the readings, we have to wait little bit time until the both liquids become rest, because some liquids might have significant thickness, so we have to wait the both arms become rest before get the reading. So in this part F, it will ask to show the water level and the common interface. Some questions will ask. Some questions will ask to represent their liquid level and common interface. So question will indicate this is the initial liquid. This is I'm going to show as HL. So they have mentioned height of the water is less, density of the water is less than the density of liquid. Therefore, height of the water column should be significantly high. This is the common interface. So this is what HW. They will ask how to minimize the parallax error. So we have to use a roller or set square, and we have to get our eye level just parallel to this common interface. What is the minimum value of HWH node that can be measured to accuracy? 1% meter ruler. So you know the least count of this YouTube is 1 millimeter. To avoid, to minimize the fractional error, percentage less than 10%. What's the minimum reading is 10.0 or above. The minimum reading is 10.0 centimeters. The gradient of the graph H naught is 1 point. What is the density of liquid? They will ask the density of the liquid. Right? So in this experiment, HL rho L is equal HW rho W. In here we have to change the height of the water column. So therefore, HL is the y-axis. Therefore, rho W over rho L into HW. So this is the gradient. So they have mentioned gradient is 1.2. The next question, you are provided with an experiment setup to find the density of kerosene oil by using YouTube. So they are going to use two different liquid, kerosene oil and water. So we have to identify which one is water and which one is kerosene oil. So out of the common interface, the liquid which has the higher height is the lower density. If the density is low, height is high. So therefore, capital A should be kerosene oil. Capital K should be kerosene oil. capital B is water. Density of kerosene is ρ1, density of water ρ2. Write expression in terms of ρ1, ρ2, H1, H2. H1 ρ1 equal H2 ρ2. So in here you have to obtain the y equal mx format. What are the two readings that we have to take? Yes, what are the two readings? First reading is the position of the common interface. The second readings are upper meniscus position of the both water and liquid column. So they have given the graph. Using the graph, I have mentioned this is the lower point, this is the upper point. You have to find the point to calculate the gradient in between such particular reading. The diameter of two arms of YouTube is different. Does the height of the height of a water for certain oil column differ from the when their diameter is equal? Height and like its cross-sectional area, there is no relationship.